Okay, we're moving right along. So we have collected our data and we used descriptive stats to get a look at the data. Now let's try and make a decision about the null. Recall we've got two ponds. We're comparing the length of fish in these two ponds. Our descriptive stats showed us, grab my pen here, that the mean length was greater in pond 1, but that was based on only 10 fish, and so we need to decide how much confidence we have in these results, and can we use these results to reject the null. Remember that our alternate hypothesis is that the fish are different between the ponds. The null, what we assume to be true, is that the fish are not different between the ponds. The descriptive stats suggested that pond 1 has larger fish, but can we trust those numbers? We'll take the descriptive stats and we'll plug them into a formula, and that's how we create our inferential stats. You remember I said the descriptive stats are used to simplify the raw data, and the inferential stat is used to simplify the descriptive stats. And we're going to reduce it down to a number that allows us to make a decision about the null. Descriptive stats describe, inferential stats infer. And they allow you to infer something about the data. They allow you to make a decision about the null, and that's our ultimate goal. So how are we going to do this? Well, do you remember the p-value? What is a p-value? I'll give you a second. Do you remember that a p-value, one definition of a p-value is the probability that the null is correct. So these inferential stats will give us the p-value, and that will allow us to make a decision. So for example, let's say our p-value is 0.75. Do we reject or fail to reject the null? We fail to reject the null. The p-value is the probability that the null is correct, and in this example that probability is 75%. That's a very high probability. It's very likely in this example that the null is correct, so we can't reject it. Another example. P equals 0.001. Do we reject or fail to reject the null? In this example, we could reject the null because there's a very low probability that the null is correct. So we can go ahead and reject it. Now, is it possible in the second example that the null is correct? Yes, it is possible. We are never 100% certain. Recall that we are sampling the fish from these ponds, so it's possible to make a mistake, okay? But the beauty of stats is the inferential stats allow us to quantify our uncertainty. And so we're never going to be 100% certain, but with these statistics, we can actually put a number on our uncertainty. So think about it this way. How sure are we? Let's say that P is 0.001, so we reject the null and say that the fish actually are larger in pond 1. Well, how confident are you in that decision? Well, you could say I'm 99.9% sure. And so I'm quantifying how certain or quantifying how uncertain I am about my results. And that is the beauty of stats. We'll never be 100% certain, but we can actually tell you how uncertain or estimate how uncertain we are. And that's why we do the stats the way we do them. All right? So, we've got this p-value. This is the magic number. This is the number that allows us to make a decision about the null. How do we get it? Where does it come from? Well, that's the tough part. That's the part that requires practice and skill and takes a while to learn. Understanding what a p-value is and how that fits into the framework of the experiments we're doing is straightforward. The only tough part is figuring out how to get that p-value. You've got to choose the proper inferential stat for your study. And there are a lot of factors that go into determining which is the proper stat. We'll talk about those later. Once you have the correct inferential stat, it's built from the descriptive stats. So again, it's a way to simplify the descriptive stats, and you simplify them all the way down into a single number called the p-value. Now, in real life, you need all these. You need both the descriptive and the inferential to really understand what's going on. This is just how the two relate to one another. The inferential stat gives you that single p-value, and you use that to decide whether or not you should reject the null. And then you can also talk about how confident am I in that decision. Okay, so I've got a spreadsheet here to demonstrate some p-values, and I'm going to show you that next, and then we'll come back to summarize.